Hi, today is section 8.6, dependent events. Last lesson was about independent events, where we have one event that does not affect the outcome of the second event. Today we're talking about the second event being affected by the first event. If on the left side of the screen here we have Amanda is going to reach into this jar right here and draw out a marble. But then before she draws a marble a second time, she's going to put that marble back in. So the first time we're dealing with 10 marbles, but the second time we're also still going to be dealing with 10 marbles. So our the likelihood that we're going to get blue each time is not going to change, because we come back to the same starting point each time. So there are 2 blue marbles in the jar out of a total of 10 marbles. And that would give us a probability of getting 1/5. The probability is 1/5 that we're going to get a blue marble. And the probability will be the same the second time because we put the marble back. But what is the probability of getting blue permutation, so that you've gotten a blue the first time and a blue the second time? You have to multiply those together. 1/5 times 1/5, and you'll see that it's not very likely that that will happen. 1 out of 25. But now we have Brian's coming up to the jar, and he wants to keep his marble that he draws. So the first time he goes to draw, he is going to start out with 10 marbles. So what's the likelihood that he'll get blue? Well, there are 2 blue out of 10 total, so the likelihood is 1/5. However, on this second draw, there is 1 marble less because he didn't put his marble back. So what is the likelihood? Oh, I just realized my picture is wrong. Let's say that he was successful in getting that blue marble. So now there's only 9 marbles in the jar. What's the likelihood that he's going to get that blue marble right there? Now we only have 1 blue, and there are 9 left in the jar. 9 possible outcomes. So to find the probability of getting blue and then blue, where the second blue there's only 1 left, is 1/5 times 1/9, or 1/45. This is about 0.02 or 2%. All right, just as a side note, before we had talked about adding up probabilities, so I just want to refresh that in your mind about why we are multiplying now, but before we were adding. This is back from section 8.1. In this, it makes the statement, the sum of all the probabilities of all outcomes in a sample space is 1. So that is the probability of getting a red was going to be 3 out of 10 pieces of candy. And then the probability of getting green was going to be 5 out of 10 pieces of candy, and the probability of getting blue was going to be 2 out of 10 pieces of candy. Those are all the different possibilities of going up to a bag of candy that contains 10 pieces of candy, 3 of them red, 5 of them green, 2 of them blue. That's the probability that you're going to get red, or you're going to get green, or you're going to get blue. It's not talking about any kind of permutation about getting red first and then green and then blue. It's not doing any of that kind of thing. Over here, we are talking about the possibility of getting blue and then blue. So that's the reason we are multiplying now, whereas before we were adding. And the book makes the statement that the sum of all of these probabilities will equal 1. So you reach into that bag of candy, you're going to get either a red, a green, or a blue. You add all of those up and you're going to get 1, or 10 tenths equals 1 equals 100%. Okay, so if you need a refresher on that, go back to section 8.1. And then here is the formula for finding the probability of a dependent event. You're going to find the probability of event A and then multiply it by the probability of event B after removing the effects of A. So we're going to walk through some of those, some examples real quick. A fish tank contains 9 clownfish, 3 crabs, 7 pufferfish, and 2 starfish. They are removed one at a time at random so the tank can be cleaned. So there are 9 clownfish, 3 crabs, 7 pufferfish, 2 starfish. There are a total of 21 creatures. 21 creatures. Now they're going to be removed one at a time at random so the tank can be cleaned. What is the probability of the first removing a pufferfish and then a crab? I'm sorry, I don't think that the is supposed to be there. Of first removing a pufferfish and then a crab. All right, so we want the probability of first getting a pufferfish, and then crab. Well, the probability of getting the pufferfish, is going to be, there's 7 pufferfish, but 21 possible outcomes because there are 21 creatures in the tank at this time. This reduces to 1/3. Always reduce whenever possible. It's going to make your numbers more manageable at the end. All right, but now the probability of now getting the then crab, that second event, you have to ask yourself, well, I have just removed a pufferfish up here. If this event were to have actually happened, I would have removed a pufferfish. That means my total creatures in the tank has been reduced to 20. And then there are 3 crabs. So the probability of getting a crab at this point is 3/20. But now I want the total probability. I want the total probability of getting the pufferfish and then crab. You see, at this second probability, that's going to be my probability of getting the crab the second time, regardless of what I got the first time. I might have gotten a starfish the first time, and then the probability of getting a crab is 3/20. I want the probability of getting the pufferfish first and then the crab. That's going to be 1/3, which I got from right here, times the probability of then getting the crab, 3/20. Now remember, reduce whenever possible. It just makes life easier in the end. So the 3 can get canceled out. 1 times 1 is 1, and 1 times 20 is 20. So the probability of getting the pufferfish and then a crab is 1/20. All right, moving on to what is the probability that the first 3 removed are the 3 crabs. 3 crabs. I'm going to switch to a different color. 3 crabs. Why did it not? Oh. 3 crabs. All right, so I want the probability of getting a crab and then a crab and then the crab. This seems very unlikely to me. So let's find out how it goes. I want to move this down here so that we can see our formula. All right, we have probability of getting a crab and then a crab and then a crab. Well, the probability of getting the crab the first time. First crab. There are 3 crabs out of a total of 21 creatures. So we'll reduce that to 1/7. 3 goes into 3 once, 3 goes into 21 7 times. The probability of getting the second crab. Now, if we got a crab the first time, how many crabs are left in the tank? There are only 2. And if we got a crab, or really anything the first time, how many creatures are left in the tank? 20. So this reduces to 1/10. So that's the probability of getting that second creature to be a crab. The probability of getting the third creature to be a crab is, bear with me a second, when we piece it all together at the very end. Now, if the first time we got a crab, there were three chances out of 21, and then that left only 2 crabs. So the second time, the chances of getting a crab would be 2 out of 20. And then if you got the crab that time, the chances of getting a crab coming up to a tank that has only 1 crab in it, 1 crab, and then we're down to 19 creatures, that's 1/19. Now, what's the chances of getting, the probability of getting a crab and then a crab and then another crab without getting any other creatures in between would be 1/7. Got that right here. And then equals 1/7 times 1/10, and then finally times 1/19. That's 190. 10 times 19 is 190 times 7. That is a chance of 1 out of 1,330 times. You'll be there a while to get this to pan out for you. 1 out of 1,330. All right, and then finally, what is the probability that neither of the first two animals removed our clownfish? Probability neither first or second are clownfish. All right, so the probability that the first is not a clownfish, first is not equal to a clownfish. To find that, remember we're going to be talking about the complement to the first being a clownfish. So we take the probability, remember the sum of all the probabilities is going to equal 1. So we're going to do 1 minus the probability of getting the clownfish. And the clownfish, the probability of getting the clownfish there are 9 clownfish out of total 21. 9 out of 21. This is going to, I'm sorry, let me go through all the steps. This is going to be 21 minus 9 over 21, and then that's going to equal 12 over 21. Now the probability of the second not equaling a clownfish. Now remember, we need to assume, for the sake of coming up with the probability of this, is that we need to assume that the first was not a clownfish. The first was not a clownfish. So we have 20 creatures in the tank now, and there are still 9. But we also want the probability of not getting one of those clownfish. So we're going to subtract that 9/20ths from 1. So we have 20 down here because we've decreased. We got a creature. A creature has been removed. We have 9 clownfish because we are trying to figure out the probability of making sure that we still had 9 in the tank. The creature that was removed was not a clownfish. So that equals 20 over 20 minus 9 over 20, which equals 11 over 20. Now, the probability of the first time you not getting a clownfish is 12 over 21. The probability of you the second time not getting a clownfish is 11 over 20. And then once again, you do want to reduce. It just makes life easier. So 4 goes into 12 3 times, and 4 goes into 20 5 times. Then 3 goes into 3 once, and 3 goes into 21 7 times. Then you get 11 over 35. So the probability of not getting a clownfish the first time and not getting a clownfish the second time, on the very first 2 times you get something out of the tank, is 11 out of 35. I hope that makes sense. Good luck with your homework. Listen to this again. Read it until it makes sense, because believe me, if I can understand it, anybody can. All right, good luck.